Since ancient times, humans have gazed at the stars and sought patterns. But it wasn't until we developed the language of mathematics that we truly began to understand the cosmos. In this enlightening episode of Infinity Beyond, we explore the mathematical universe hypothesis. The idea that mathematics doesn't just describe reality. It might be reality. Our journey begins in the 17th century. Isaac Newton revolutionized science by formulating laws of motion and gravitation using mathematics. He showed that the apple falling from a tree obeyed the same principles as the moon orbiting Earth. This was a stunning realization. The heavens and the earth are governed by the same universal math. Fast forward to the 19th century, and we meet James Clerk Maxwell. Maxwell unified electricity and magnetism into a single, elegant framework. Electromagnetism. His famous set of equations not only described existing phenomena, they predicted something entirely new. According to his math, electromagnetic waves should exist, and they should travel at the speed of light. A few decades later, Heinrich Hertz confirmed Maxwell's prediction experimentally. And with that, humanity learned that light itself is an electromagnetic wave. This was more than just a scientific victory. It was a triumph of pure mathematical reasoning. It suggested something profound. Math can see beyond what our eyes can. It can reveal hidden layers of reality, unseen until we decode the numbers. Then came the 20th century, a golden age for mathematical physics. Albert Einstein, armed with nothing but thought experiments and mathematical logic, developed the theory of special relativity in 1905. His equations rewrote how we understand time, space, and motion, especially at high speeds. A few years later, he completed general relativity, a theory of gravity not as a force, but as the curvature of space-time itself. And once again, the math predicted something that seemed outrageous. Light should bend near massive objects. In 1919, this was tested during a solar eclipse. Starlight passing near the sun was observed to bend, exactly as Einstein's equations predicted. Suddenly, math wasn't just describing the universe. It was anticipating it. And the pattern continued. Quantum mechanics, born in the early 20th century, is built almost entirely on abstract mathematics, matrices, wave functions, probability amplitudes. The weirdness of quantum reality, superpositions, entanglement, tunneling, all come from mathematical formulations. Despite being utterly counterintuitive, the math has never failed. It guides the design of lasers, computers, GPS satellites, and even medical imaging. So here's the big question. Why is math so uncannily effective? Is it just a tool that humans invented? Or is it the underlying code of the universe? The idea that the universe is math is not new. Pythagoras believed numbers were the essence of reality. More recently, physicist Max Tegmark has proposed that the universe is literally a mathematical structure. That is, reality isn't just described by math, it is math. Every particle, every law, every dimension is part of a vast, coherent mathematical object. It's a radical view. But it explains why math works so well. It also raises deep philosophical questions. If the universe is math, then why these equations and not others? Are all possible mathematical structures real in some sense, each forming a different universe? This would be a kind of mathematical multiverse, where each consistent set of equations defines a unique reality. And we happen to inhabit one that allows complex structures like galaxies, planets, and conscious life. Skeptics argue that we shouldn't confuse models with reality, that math is just the best language we have for now. But time and again, mathematical predictions come true. Black holes, antimatter, gravitational waves, these were all predicted mathematically before they were observed. And in physics, we often find that beauty and symmetry in equations leads us to truth in nature. So maybe the universe is not just mathematical, maybe it is mathematics made manifest. This view has practical consequences too. If reality is mathematical, then finding the final equation might mean understanding everything, the theory of everything. That's the dream of physicists, a single elegant equation that unites general relativity and quantum mechanics into a complete picture. String theory, loop quantum gravity, and other models all seek this unifying framework. And while we're not there yet, the journey is guided by math, always math. From the orbits of planets to the vibrations of quantum fields, from the shape of black holes to the expansion of the universe, everything follows the script of numbers. So the next time you look up at the stars, remember, you're not just seeing lights in the sky. You're seeing geometry in motion, equations unfolding, math dancing across space-time. And maybe, just maybe, you're part of the grandest equation of all.